I've written this tutorial to show you how to fully automate the build and the deployment of your microservices to a Kubernetes cluster, and I've combined it with automatically creating the cluster and deploying all the services in one with one step. So I've combined some technologies that are pretty popular in the uh, DevOps community right now. And so I'll kind of go through the components of the application and how it gets deployed. So I've broken this up into different Git repos, and there are links on this table of contents. And I'll take this video and I'll link it to this repository, and then I'll link the repository to the video for reference. So there's a containerization step. So if you have an application that you want to deploy, the easiest thing you could do with that application is to containerize it. So I have an example of a Python app that has a build step that works with GitHub, the GitHub Actions that builds the Docker image and pushes that to GitHub. And then there's another repository that is a set of Kubernetes manifests that will tell Kubernetes how to deploy that application. And then also I have a second repository that will gather up the manifest from the second step along with some Helm charts that I want it to deploy to Kubernetes. And I use ArgoCD AutoPilot to kick off the deployment of all those applications, basically bootstrapping all those applications. And the final component, which is actually the component that essentially controls the building of the cluster and the bootstrapping of ArgoCD, that's in a separate repository that has my Terraform scripts in it. And then there's some documentation in here as to which component does what, and then a diagram that shows how those repos basically interact with one another. So you can look at that for reference. So let's take a look at the containerized app. Okay, so this app is a very simple app. It just has um, uh, a Python service that just listens on port 9090, and it just returns a result when you hit it from a browser. So this is like an example of how you could containerize an app. This app essentially doesn't even know that it's going to be deployed to Kubernetes at all. It has the Docker file that tells it how to be containerized, and then there's some GitHub workflows that will build the app, push it to Docker Hub, and then there's it's based on the philosophy of doing a pull request. So later on I'll create an issue, work on the issue, do a pull request, and then when it gets merged to the main branch, then it will push that image out to Docker Hub, and then I have ArgoCD Image Updater watching for updates, and it will automatically deploy. So once this thing gets automatically bootstrapped, this app is geared to just all you have to do is just start working on the app, and it will automatically get its updates pushed out to the cluster. So the second app is the app that has all of the Kubernetes manifests. So this app has all of the manifests in it that tells Kubernetes how to deploy the app that we just looked at. So it has all the YAMLs that are necessary for Kubernetes to deploy the app with the deployment, and it has a service. And so what's going to happen next is the ArgoCD component, and we can take a look at AutoPilot. AutoPilot has has this app that we just looked at. It has the Hello GitHub webhook. That's basically the app that we just looked at. This tells ArgoCD how to deploy it, and there's some instructions in the AutoPilot repo that tell you how to bootstrap the repo depending on what Kubernetes context you're pointed to, and then to deploy not only the simple Python app, it'll also deploy these cluster add-ons. So let's take a look at the cluster add-ons, which is in a different repo. So cluster add-ons has essentially a list of Helm charts: Cert Manager, Grafana, Prometheus, and it's an ArgoCD application set. So AutoPilot will look at this repository and it will automatically deploy anything that's in the add-ons folder. Okay, so if we take a look at our Kubernetes environment, we're going to deploy this on Azure. So let's take a look at my account on Azure and see what's deployed. There shouldn't be anything on it. All right, so if you can see here, these are all of the resources that are currently deployed to my Azure environment. There's this network watcher which seems to always run. So this cluster, the cluster that we're going to build, it's not in this dashboard yet. So let's go back and look at the table of contents. Okay, so I've covered the application, the very simple application, how that application is packaged up and deployed to Kubernetes. The this section covers the GitOps. So GitOps, it is a philosophy of deploying to Kubernetes where Git is the source of truth. So ArgoCD is an implementation of that. And then AutoPilot is it's basically like an add-on to ArgoCD that allows you to bundle up all of your apps that you want to deploy when the cluster is built. Okay, and then this Terraform. The last thing we'll look at is the Terraform application, and that's when we're going to run the demo to actually build the cluster. Okay, so this is Terraform. The Terraform repo has instructions as how to set up your account to point to Azure. So if you have an Azure account, you can follow these instructions, and it will basically deploy everything that my AutoPilot repo is pointing to. But you can, like, if you want to, fork off of AutoPilot and have your own AutoPilot point to the Kubernetes manifests that you want to deploy. So you can kind of use this as a template. So the first thing I want to do is source in my secrets, and my secrets have all of the variables that are mentioned here, the tenant ID, and there's there's a key and so on. So once that's sourced in, what I should be able to do is, I've already run the Terraform init. That's just going to download the modules that are needed for Terraform to work. So that I shouldn't have to run that again. What I want to do is run this plan. Okay, and I want to change the name of the cluster. This example has the name of AKS getting started. I'm going to change this to demo. Okay. And the Terraform plan is going to tell us all of the modules that or all the resources that Terraform is going to create with the apply. Okay, so let's look at the plan. It is going to it's going to download ArgoCD. There's an ArgoCD AutoPilot CLI that you can use to bootstrap your AutoPilot application. So I had to write my own Terraform modules to do that. There was several ArgoCD modules on the Terraform registry, but I couldn't find one on ArgoCD AutoPilot. So I wrote one that downloads that CLI program, and then there's also another module that will bootstrap the cluster, and that's run at the end. So this is going to create the cluster, and then create the resource group. It's going to download the kubeconfig file so I can work with it locally. It's going to create a namespace for ArgoCD, and there's some Git credentials that I need for ArgoCD's image updater to work properly. So I put that all in this script. All right, so let's run the script, and this time we're going to do the apply. And I really wanted this to be called demo, not plan. So the name of the cluster is going to be called demo. Okay, that looks good. Let me run that plan again with those changes that I just made. Okay, it looks good. This time we'll run the Terraform Apply. This first part is downloading the AutoPilot CLI. At this point, the cluster should be in a create state. We should start to see the cluster come alive in the Azure Portal. So we're getting some components that the cluster needs. This is the name of our cluster's demo. Okay, at this point the cluster should be functional, and now it's installing ArgoCD AutoPilot, and ArgoCD AutoPilot is going to bootstrap the sample app that I have, and then those cluster add-on Helm charts that I want installed. Okay, everything should be running. Now what I want to do is download the credentials file. I should, it would have already downloaded a copy, but I want to override my kubeconfig so I can do it with this command. I'm just going to change this sample name to demo. Okay, so the cluster is running. Can pretty much tell based on the age of the application. All right, let's take a look at ArgoCD running in the cluster. Now that the app has been bootstrapped, ArgoCD is now in charge of any changes that I want to make to the cluster where I want the Git ops philosophy to be enforced. So I'm going to port forward into ArgoCD. I need to get the initial logon secret from the cluster to log into ArgoCD. Okay, so that's found here. If I hit X, it'll decode it. And I'm using K9S to view the cluster. So admin is the default username, and then that password that's automatically generated should take me in. Let's try that again. There, we're logged into ArgoCD with that username and password. And these are all the apps that ArgoCD bootstraps. So we'll see the hello GitHub application is right here, and there's Prometheus and Grafana, and so it deployed everything that I wanted. We could look at everything that is deployed through the UI. Okay, so now that everything's running, let's say for example I want to start working on that sample app and I want to do a new release. Let's take a look at the release that's there. Okay, so it's running, notice it's running 408. Now everything is automated. So now as long as we follow a certain protocol with working with that application, everything will be versioned and automatically updated. So let's go to that application. Okay, so this is the app. Sorry, I have all of the latest in my local repository. It's pointed at the main branch. And let's start a new issue to work on. And I want to work on this issue and do a pull request against that issue and then have it automatically deployed. So first thing I'm going to do is create a new issue to work on. So we'll come down here, we'll create an issue. Okay, so this is a demo issue, and I'll assign it to myself. Okay. Okay, that would have created the issue with GitHub. And now I want to start working on the issue. So all I have to do in VS Code to start working on the issue is the issue is number 51, and I'm going to hit the arrow right here, and that will automatically create a branch. So now I'm on dev 51 is my branch. It's also visible here in my prompt, and we'll make a change to the app. Okay, so we'll just create a new service, and there's a health service, there's a demo service. We'll call this our sample service. Doesn't really matter what we call it. I just basically want to show that the code has been changed and we can get a new application automatically pushed out. Okay, so now what I want to do is commit that, and this is also an important step. So the GitHub work, I'm using the SemVer I'll call it the SemVer pattern for doing releases. So that follows the major release, the minor, and the bug fix. So if I want to push out a new release and have everything automated as far as the change log and what the next version is going to be, I have to follow a certain naming standard when I do my commit messages. So for this, if I put a fix in here, I'll be bumping the rightmost number. If I put a feature in here instead of fix, that would bump the middle number, and then the major would be if you put breaking change and I usually just put breaking change in all caps with a colon, and then that would bump the first number. Okay, so what I always like to do is reference the issue number in the release, so it'll automatically realize that there's an issue open. So here's number 51, and this essentially will be my commit, but I could put any changes to this message that I want. So I'm gonna stage that file and then do a commit and push, and it's going to say, hey, this branch doesn't exist on the remote. You want to push it? Yes. And then I want to automatically create a pull request, and then here in my pull request I'll say that this is when I merge this in, I want to close this issue, so it'll close 51 automatically. So I'll create that pull request, and if I go to the pull requests, I'll assign that to me, assign to myself, and this pull request would show the changes that need to be merged in. Ideally, you'd want to have somebody else review that pull request before it gets merged into main, but this is just a demo, so me reviewing it right now is good enough. So what the GitHub actions are going to do is it's going to trigger the pipeline to build the dev branch, and I don't have a cluster set up right now to track the dev deployments. You can actually do that with ArgoCD Image Updater. You can set up ArgoCD to the best way I've seen it done is, or my experience is, use the where you change the digest. It watches the digest, so every time you, let's say I'm working on a dev branch or a numbered branch, let's say this dev 51, every time I do a commit, the branch name or the build number it could be the same, dev 51, and CD may not pick that change up, but if you set the deployment to use the SemVer strategy for ArgoCD Image Updater, it will see that the digest number is changing based on the Docker image has different contents in it. But this is just basically kind of set up to show how you could maybe work with it in production. So what we just did, if I look at my git log, we'll see that this is my last commit, and right up here there's that build that just ran. It was referencing that commit hash, so that I know this build ran. It built the Docker image, pushed it to Docker Hub, and I have some Python tests that are running. And if you really want to automate your deployments, you want to have a lot of tests that are going to check your code to make sure it's going to work before you push it out. And actually within here you can run those tests also within VS Code if you want. Okay, so I'm happy that I believe that this build is gonna work, and I'm gonna look at that pull request, and here's the pull request. It's I can click on this, it'll show me the code that's changing, and so I'm ready. And if I want to review the code or all the commits, that's visible here. These plugins that VS Code has for interacting with GitHub are fantastic. You basically don't even have to leave the IDE to push out your code. You can stay within it, create your issues, do your pull requests, watch the builds with the GitHub Actions plugin for VS Code. It's probably one of the best IDEs I've used, and coupling that with GitHub offers a lot of offers you to be really productive within the IDE. Okay, so I'm going to merge this pull request, And I already got my comment up here to close 51, so I'm going to hit merge, create merge commit, and then I'm going to hit this button to delete the branches. This is a nice feature that they've got in here. It'll delete the remote branch and my local branch. Okay, so now let me pull in my any changes. Now let's take a look at the GitHub Actions. What's that? What is that doing? So now I have a new commit. If I look at my Git log, let it run through that build process. And what's really cool is, let's see if I have okay, so now 409 has been automatically produced. That tag was automatically produced by the GitHub action workflow, and then there's a new Docker image that's been pushed out to GitHub. Let's take a look at that repository in GitHub, or GitHub. So I want to stay on this guy right here. And I want to switch back to the browser. Let's take a look at GitHub. And we want to take a look at that repository. Here it is right here. And notice here that there's a new release, so the workflow has automatically produced the change log. So that change log is going to reference the build number that was worked on, and then any commits. So as long as you follow that SemVer pattern, if you just do a SemVer, I'll probably put a link in the video to show you how to do that. If you follow that commit pattern of fix, feature, and breaking change, and then your comment, your comment doesn't have to include the issue number, but I think it's a good practice to do that. If you follow that and then use that workflow that's in this sample, it'll do all this stuff automatically. Okay, so 409 was produced, and let's go back to ArgoCD, and let's take a look at this application. So this is the really cool part. So what you're seeing here is, notice that it just built and pushed out version 409 of the Hello GitHub webhook app, and I didn't have to do anything in ArgoCD manually to make that happen. It was all automated by the ArgoCD Image Updater, and ArgoCD Image Updater is watching. It can watch a Docker repository or a container repository for new changes, and if your SemVer pattern allows it, it will automatically release, let's say for example, a bug fix. So my SemVer pattern in that code, and you can see it in, I think it's in the AutoPilot repository. That SemVer link is saying that I will allow any major versions to go out that go up to 4, and any break fixes and any minor changes that'll go out. And ArgoCD Image Updater will see that there's a new image, and then it will automatically bump the repo that's tracking all the YAML for the application. So if we take a look at okay, so there should be a new change, and we can see it in the change log. let's look at all the commits that have come in. So this was the automated change that happened with ArgoCD Image Updater. So it automatically changed that version number, and then once that changes, essentially this file is part of the ArgoCD Image Updater framework, and this guy right here, that number is going to take precedence over what we have in the values file. So the values file, notice, has version 4.0.0. The ArgoCD is basically going to ignore that and go with what's in this override file. So ArgoCD Image Updater is running in my cluster that I just built. It has a credential. I could show it right here. If I do kube get secrets on ArgoCD, it needs this get credentials, and it has rights to write back to my Git repository to make a change like this. And then once that happens, ArgoCD is just going to do its regular job, and it's going to bump the number because it's watching. ArgoCD is watching this repository for changes. This change came in. I mean, it came in an automated way, but like ArgoCD doesn't really care about that. It's just seeing that, hey, there's a new number, and then I'm going to roll it out. So once you have ArgoCD and ArgoCD AutoPilot set up, you can bootstrap all of your apps, and if you're using Image Updater, it'll do everything automatically. So that's the sample app that gets rolled out. So what about the cluster add-on? So let's take a look at that. Let's say I want to roll out a new change for that. Let's switch over here to this add-ons folder, so that's that's a pretty common practice. Like, you want to roll out your own custom apps that you write, and then you probably have a bunch of third-party off-the-shelf apps or Helm charts that you want to deploy. I haven't worked on any Kubernetes clusters that don't include some kind of third-party Helm chart. So I use the ArgoCD application set, and it's just going to monitor this folder and then roll out any changes it sees. So right now, if I do kube get applications on ArgoCD, you'll see that like Grafana is deployed, Cert Manager is deployed, Prometheus is deployed, because it's ArgoCD is AutoPilot picked up that all these applications are in this folder. So ArgoCD is actually watching this repo. So if I look at this repo, it's got its own address and so on. So if I make any change, and this is the head or the master of the repository, if I make any change to this, if I delete one of these or add something new, ArgoCD is going to automatically pick it up. So let's add something, and we'll show that ArgoCD is going to automatically deploy it. Let's deploy Tomcat. Alright, so what I want to do is I want to go into, I'm in the right folder, and then I also use Customize. So ideally, you don't want to have a bunch of different branches for your deployments. You want to work off of one deployment branch and then use folders to handle any kind of differences for your different environments. That's the strategy that ArgoCD is encouraging you to use. So what I did was, let's say for example you have a bunch of different environments. This application set that I've got here for dev, I think I have ArgoCD pointed to the ArgoCD AutoPilot is actually pointing to the dev overlay, and all this is going to do is it's going to look for this dev values file. So if I want to deploy Tomcat, what I need to do is do a Helm. I'm gonna fetch Tomcat. Cat, and then untar it. Okay, and then what I want to do is go into this repository. Let's go into Tomcat, and let's copy. We just want to. All right, because that this dev file is required because my overlay file is looking for an overlay to have values dev file in every Helm chart that I want to deploy. So let's add this. Okay. Push that out. And ArgoCD should see Tomcat has been committed to the add-ons application. See if Tomcat is available. Yep, there it is. Alright, this time it's deploying nicely. That pod is starting up. So the first time I went through, I had a typo in my values demo file, which caused it to hang up. Alright, this time Tomcat deployed properly. ArgoCD AutoPilot saw that there was a change to the repo of the cluster add-ons, and it deployed Tomcat. Now if I want to remove Tomcat, I don't want to do it from the cluster, I want to do it from Git. So let me switch back over to the add-ons repo, and I could simply delete the folder and make that change, and then delete Tomcat. Commit and push that. And if we go back to Argo, we should see that Tomcat is being deleted. Okay, that worked out better than having. I mean, that's the nice part about it. You can make a mistake in your commits, and you can clean. If you clean up those commits, ArgoCD will be able to eventually figure out what the proper endpoint is. So if you're not happy with what you're doing in your commits, you can just keep working on it until ArgoCD is happy. Alright, so that shows how you can do a deployment through the cluster add-ons. It shows how to do a deployment through the sample app, which that got bumped automatically. And so I guess the last thing somebody may want to do is, let's say you want to roll back. Let's say going back to this sample application, the Python application. Let's say you want to roll back this 409 to 408. Well, how do you do that? There's a couple different ways to do it. So let's go back to that repository, and so within here we'll find we actually want to look at You could make it. I mean, here one option is to actually go in and find that commit and see what work was done. You could undo the commit, and then do a pull request, push that out, and you would get a build 4.0.10. That's probably the best approach. And the other approach is to go to the repository that has all of the Helm manifests. So okay, that's this guy. So if we take a look at our graph, this is a nice plugin for VS Code called Get Graph. It shows me all the changes that have come in. So it should be I think ArgoCD should be tracking this commit. So if we do a get applications T, we go out wide, it should show me the hashes. Okay, so my application is this webhook, so it does track. Notice that. So you definitely have to understand how the git commits and the hashes are working, and know which repo GitHub ArgoCD is tracking. So in this case, it's tracking this this guy right here, DCE, and notice that commit right here. So if I want to roll this back to this commit, so this commit had the 408, okay? Because if we look here, this committed 409 during this demo. So let's say I want to go back to 408. Well, I need this hash, okay? So let's grab it. You can actually, you can copy it from here. There's lots of different ways to get it, but let me copy it. Copy hash. Okay, so I'm gonna copy this to my clipboard. And now, because ArgoCD AutoPilot is in charge of what's getting deployed, I need to go to that repository. So let me go to AutoPilot. Okay, so here's AutoPilot, and let me just make sure I have a fresh copy of everything. What I want to do is, and I think it's just going to happen right here. So notice it's tracking the head. If I change this in AutoPilot, so this is its own repository, it's going to track, and I think that probably the best rule of thumb is to, if you have one AutoPilot repo per cluster, I think that's the easiest way to manage your clusters if you want to use AutoPilot. If I want to make that change, I think all I have to do is just put that commit, the previous commit here. I don't think I have to do any other changes to here. Alright, let's try that. Let's see if that rolls it back. And I think it's always good to figure this out ahead of time, because if you really wanted to use this technology, you'll probably find yourself in a situation where you will have to roll something back. So figuring this out all in advance is worth your time. Alright, so I'm going to roll this thing back. I want to roll back my hello. I want to get back to, I think it's 408. Let's see, roll back to, which is version 408. Make that commit and push. And let's go back to the browser. Okay, see, it's already picked up that change. It's now syncing. So this is a way to roll back. If you know that hash code and you know which repo ArgoCD is pointed to for its deployment, it's going to it's already spun that thing up. So it's going to delete this replication set, and then so it's essentially rolled back to 408. And then if I want to undo that and go back to the current version, all I have to do is really revert that change that I just made. So if I go back here, and not this guy, it's AutoPilot that we're interested in. Okay, here's AutoPilot, and I look at my my changes here. This was the change I just made. I can basically just revert my commit and then push that back. Should go back to head, and I should get a new commit hash. Yeah, here's my revert 1A, so I should see 1A now. Okay, so if I go back here, and we can see it right from here. If you want to look at it from the terminal, we just do get applications cd, and then let's go out wide. We'll see our hashes. There's our webhook. And we want to see 1A go out. Okay, there's 1A. That's a good sign. And if we go back, oops, let's go back to the browser. Actually, we can see it from here. So kube get pods on. Let's get to kube get ns, and we want to look at recreate my connection. Yep, it rolled back to 409, or I should say rolled ahead, because it's pointed ahead. So that's it. You can, if you let's take a final look at these instructions, this guide. These are all the components we just went through. Once again, the customize, the containerize one, there's a link here. It's just the Python code that's doing the Docker build. This repo has got the YAML that tells Kubernetes how to deploy this. The AutoPilot repo is based on ArgoCD's AutoPilot technology, and it has the it's pointing to this repo, this CD repo here, and then it is also pointing to a cluster add-ons repo that is the one that we use to deploy Tomcat and Prometheus and Grafana. And then the one that kicks it all off is Terraform. And then down here at the bottom is a diagram that shows all these components work together. The developer is containerizing that application, push that's getting pushed to Docker Hub. And then the DevOps party's coming along, and it's bootstrapping AutoPilot with Terraform, and that's kicking off the creation of Kubernetes. Is actually bootstrapping Kubernetes, and in this example, Azure AKS, and then it's also running the AutoPilot bootstrap. And then once that's done, you can let AutoPilot take over and manage all of your applications through AutoPilot. That's it. You can put any comments in the video for questions or comments. Thanks for watching.